Today we're going to be talking about simplifying radicals, or in other words, simplifying square roots. Now, before we get started with that, we're going to, on the top of our paper, write out the perfect squares from 1 to 12. So, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. And saying something is to the second power is the same thing as saying that it's squared. So 8 to the second power is 64, and we have 81, 100, 121, and 144. So having these up here will allow us to quickly determine if our number is a perfect square or not. Now, when we are talking about perfect squares, it is also important to realize what that means in reverse. So yes, we know that the square root of 9 is 3, and that 3 to the second power, or 3 times 3, is 9. But we also have to think about negative 3. Negative 3 to the second power is also 9. Negative 3 times negative 3 would be positive 9. So we would say that the two square roots of 9 are 3 and negative 3, because when we square both of those values, we get 9. Now, the product property of square roots, what this allows us to do is to split things up in our radical, or our square root. So we could write the square root of 18 as the square root of 6 times the square root of 3. We wouldn't want to do that because neither of those numbers, 6 or 3, are perfect squares. So when we break this 18 up, we want to find two factors where one of those factors is a perfect square. 6 and 3 are factors of 18, but neither of those are perfect squares. So instead, what we should do is break it up into the square root of 9 times the square root of 2, because the square root of 9 is 3. We have that up here. And we can simplify that. So then this would equal 3 times the square root of 2, because we can take the square root of 9, but we can't take the square root of 2 and get a whole number. The quotient property allows us to separate these square roots. So we get the square root of 2 divided by the square root of 25. Well, now we know that we have the square root of 25 on the bottom. We can simplify that and give us the square root of 2 over 5. The quotient property allows us to do that. So to summarize what we're going to be doing, when you look down here, square root expression is simplified if the following conditions are true. No perfect square other than 1 is in the radicand. The radicand is just the square root. And then we have no fractions in the radicand, so no fractions under the square root, and no square root symbol or radical appear in the denominator of a fraction. No radical or radicand appears in the denominator of a fraction. We're not going to focus on that a lot today, but it's basically improper math to have a square root in the denominator. So if we look at our examples down here, we're going to break these up into two factors where one of those factors is a perfect square. Remember, a factor is a number. Two factors are numbers that multiply to my given number. So factors of 12 could be 6 and 2. 6 times 2 is 12. 4 and 3 are factors of 12. 1 and 12 are also factors of 12. So with the square root of 75, I want to break this up into two factors where one of those is a perfect square. So we can go 25 and 3. Now the square root of 25 is 5. And we can't take the square root of 3. Like, that's not a whole number. So then we just leave that alone. So then our answer will be 5 times the square root of 3. For letter B, we see that we have a square root, and then we have a fraction in it. So we can rewrite this. We will rewrite this as a square root of 11 over the square root of 144. Now, the square root of 144 is 12. And we can't simplify the square root of 11. That does not have two factors, or one of those is a perfect square. So this is our final answer. Now, letter C, this one, there's a couple ways that you could do this one. It can be hard to try to figure out the biggest perfect square. You know, if you can look at this and say, well, I know that this is going to be 36 times 2, you're going to get to your final answer a little bit quicker. Right? The square root of 36 is 6, and we can't simplify the square root of 2, so we leave that alone. And here is our answer. However, if you can't see that 72 is 36 times 2, you can start smaller. You can start with 4 or 9. So if we have the square root of 72 and we break that up into, the square root of 9 and 8, and then you say, okay, the square root of 9 is 3, and then we're left with the square root of 8. Now, one of the biggest mistakes I see students make is that when they go from the square root of 9 to 3, I will see students just get rid of the square root symbol and just go to 9. When we take the square root of something, when we get rid of the square root symbol, we're using it up. It goes away. I've also seen this and say, okay, the square root of 9 is 3, and then they will still write the square root bar, the square root symbol. We're using that up, so it would go away. Kind of like if we're doing 4 plus 7, okay, that equals 11. You don't see that plus side over here anymore. We use that up. We use this addition symbol to get my new answer, and it's been used up, it goes away. So same idea here. We used up that square root symbol to reduce, or to change 9, the square root of 9, to give us 3. Well, then we have this to worry about. Okay, so this can be 4 and 2. And this 3 just keeps on hanging out at front. No big deal. Now the square root of 4 is 2. So we're going to have 3 times the square root of 4, which is 2, times the square root of 2. Well, since these two numbers now are outside of the square root symbol, we can multiply those. 3 times 2 is 6, and then the square root of 2 is still just hanging out, and there's our final answer, which was the same as we got when we broke up 72 into 36 times 2. So you can break these up in any way as long as one of those factors is a perfect square. You just might have to keep going to get your final answer, but you will get the same thing. Letter D. Okay, the square root of 5 we cannot simplify, and the square root of 36 is 6. So this is our simplified answer. So on the next page, I want you to try these 4 problems. So go ahead, pause the video, try these, and then once you're done, unpause it, and we will compare answers. All right, so here are the answers. So for letter H, I just want to talk about that real quick because there's 2 ways you could have done that. You could have broken that up into the square root of 256 over the square root of 4. Then the square root of 256 is 16, and the square root of 4 is 2, and then 16 divided by 2 is 8. Or you could have just went from the beginning and said, okay, what is 256 divided by 4? Can you do that, and does that give you an answer, an answer that's a square root? And in this case it does. 256 divided by 4 is 64, and the square root of 64 is 8. That doesn't happen frequently, but it is something to kind of look out for to see if it makes things a little bit easier. But what I have written in green will always work. Now we're going to take what we learned about simplifying radicals or square roots and apply that to solving equations. The other day we left answers as decimals, but now we're going to make them in simplest radical form. So x equals plus or minus, because we're taking the square root to solve this problem, the square root of 96. So then we need to simplify the square root of 96 and think about, okay, what 2 numbers multiply to 96, and one of those numbers being a perfect square. To me, it's going to be 4 and 24. Those are the 2 that come to my mind right away. So then the square root of 4 is 2. We have 2 times the square root of 24. Well, then the square root of 24 can also be broken down into the square root of 4 times the square root of 6. And then we have the 2 hanging out here. The square root of 4 is 2. And then we're left with the square root of 6. 2 times 2. 2 times 2 is 4. So we're left with 4 times the square root of 6. So that means x equals plus or minus 4 times the square root of 6. Now at the beginning you could have broken this 96 up here as 16 times 6, and you would have gotten this answer a little bit quicker. To me, I didn't see that right away, so that's why I started with 4, and I would still get the same answer. Letter B, first we're going to add 3 to both sides. We get x squared equals 20 to the square root of both sides. We get x equals plus or minus the square root of 20. Break this up into square root of 4 times the square root of 5. The square root of 4 is 2. So we would get x equals plus or minus 2 times the square root of 5. Now, letter C is a little bit more difficult because we have x plus 5 in parentheses, which is squared. So first, let's divide everything by 5. So we get x plus 5 squared equals 50. Then we'll take the square root of both sides. So we get x plus 5 equals plus or minus the square root of 50. So then we're going to break this up. Before we worry about this plus 5 on the other side, I want to break up the square root of 50 because I don't want to subtract 5 from both sides and then get this minus 5 confused with my radical. So let's break this up into the square root of 25 times the square root of 2. So x plus 5 equals the square root of 25 is 5 and the square root of 2 is 2. So now I can subtract 5 from both sides. And when you do that, whoops, let me go back real quick, and I forgot about the plus or minus. So x plus 5 equals plus or minus 5 times the square root of 2. So then we'll have our two separate equations, x plus 5 equals negative 5 times the square root of 2, and x plus 5 equals positive 5 times the square root of 2. In both instances, we're going to subtract 5 from both sides. Now, you cannot combine these two things. You cannot combine negative 5 times the square root of 2 minus 5. Those are two separate things. So we're not going to combine them. We're just going to leave them separate. So x will equal negative 5 minus 5 times the square root of 2. And then over here, when we subtract 5, we'll get x equals negative 5 plus 5 times the square root of 2. So that one was a little bit more involved because we had that x plus 5 in parentheses, which was squared. So our answers look incredibly ugly right here. Oops. But that is as far as we need to go. You won't see many like that, but it's good to know how to handle that. So thank you for watching these notes. Make sure you hit the like button and subscribe.